Let's begin. Today's July 26th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 2, 10, 12, 18, 21, and 22. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A looks at our first digit, the triangle digit, and compares it to the number 3. So should the value of triangle be less than 3, should it be equal to 3, or should triangle be greater than 3? Criteria card B looks at the 3-digit solution, and the Turing Machine will let us know how many of those digits are 4. Are there no 4s? Is there a single 4? Perhaps 2? Maybe even all 3 are 4. Criteria card C will look at our first and last digit, our triangle and circle, and compare them to each other. So should the value of triangle be less than circle? Should they be equal? Or should the value of triangle be greater than circle? Criteria card D again looks at our 3-digit solution, triangle, square, and circle, and will add the 3 digits together, and the Turing Machine will let us know whether the sum of the 3 digits is an even quantity or an odd quantity. Criteria card E looks at the 3-digit solution and will let us know a little bit about its structure, so to speak. Specifically, is there a pair in the solution, as in the example 131? Or perhaps it could be the alternative, no pairs, but there are 2 scenarios. One where all the digits are different, as in the example 134, or all digits are the same, as in the example 222. And finally, criteria card F will let us know a little bit about the ordering of our 3 digits, from triangle to square to circle. Should the digits appear in an ascending, meaning increasing order, as in the example 131? Could they be in a descending order, meaning that they're decreasing, as in the example 421, or could they have no order? So let's look at the example 231. Notice that it initially starts at 2, goes up to 3, but then goes down back to 1. So that shift from increasing to decreasing, or as in another example, it could be decreasing and then increasing, but it's that shift that is one way to define no order. And there have been other cases, specifically when 2 consecutive digits are equal. There's no change there, so that can also be defined as no order. And remember, the objective of today's puzzle is to find this unique 3-digit code that abides by all 6 criteria cards. And we're going to begin with an initial proposal of 314. So the first thing I'd like to test is I'd like to know whether perhaps maybe there's a pair or no pair. So let's go ahead and test criteria card E. Okay, so if you notice in my proposal, I do have 314. They are all distinct, so there is no pair. So let's go ahead and type that up in the notes in section E. The solution has no pairs. Okay, so yeah, they are going to be, well, they can either be all distinct or all the same. But I imagine that if they were all the same, since we have a card that is querying 4, I guess there could be no 4s, and you could still have 3 of the same kind. But if we knew it was the same digit repeated, then we know there was no order. And so I think that would make this card irrelevant. So I think it's safe to say that, yeah, the solution is going to have all distinct digits. And which means then that criteria card B, it's a 50-50. It's either the 4 is there or it's not. Okay, so we do have all distinct digits. Let's test criteria card D. Okay, so in this case, the Turing Machine does not approve of my proposal. Notice that I do have 3, 1, 4, so let's go ahead and add them up. So 3 plus 1 is 4, 4 plus 4 is 8. That is an even quantity, but the Turing Machine does not approve of it. So that means that the sum of the 3 digits is actually odd. So let's go ahead and type that up in section D. Triangle plus square plus circle should be odd. And that does reveal something, that if I do have distinct digits, if there is going to be an even, there has to be 2 of them, meaning 2 and 4, no pairs, right? Because if I add up the 2 evens, that sum is even, but that means that third digit, whichever it may be, must be odd. So I could have 2 evens and an odd, specifically 2, 4, and then if the other case is they're all odd, all uniquely odd, 3, 1, 5. And so that brings up a good opportunity. As I mentioned earlier, criteria card B is 50-50. So if there is a 4, and I do have a 4 in my proposal, if there is a 4, then there has to be a 2. And if not, then it's all odds. So let's go ahead. I think that's a great card to test going into round 2. So let's go ahead and test criteria card B. Okay, so there is no 4. So that means that all digits are odd. So let's go ahead and type that up in section B. There is no single 4. All digits are. And yeah, I'll just odd. Okay, so that means there are actually no evens in our solution today. Let's cross out all the evens then. That's very interesting how the combination of these 3 cards would help us eliminate all the evens. That's one of the things I really like about the Turing Machine board game, that these combination of cards just yields an interesting code or solution. It's just, I don't know, I'm a numbers guy, so I like that. Okay, well, again, that does it for this round. We've already completed our 3 Turing tests for round 1. Now we're going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A, looking at triangle. At this point, we know that if it's less than 3, it must be 1. It could be 3, or if it's greater than 3, it's 5. I do like the fact that, hey, it could be 3, and there's really no guessing, but we'll see. And so, again, we're dealing with all odds, so somehow we're comparing the first digit to the last digit. And notice that, I guess, besides criteria card F, there really is no mention of square, other than, I guess, criteria card D as well. It's in there, but not exclusively or explicitly. So somehow this ordering could come into play. Okay, so somehow the criteria card A and then C should decide it. All right, well, let's just pick something, and I'll say 315. All right, so Let's go ahead and, yeah, I'm interested in that premise. Let's go ahead and test criteria card C. Okay, so triangle is not less than circle. And of course, it can't be equal since we've already established that they're all distinct and there are no pairs. So that means then we can deduce that triangle should be greater than circle. And that's C. So let's go ahead and type that up. That, again, triangle is greater than circle. Okay, so if triangle is to be greater than circle, what can we say? Triangle cannot be 1 because what could be smaller than 1? Can't happen. And I think similarly, circle can't be 5 because if circle's 5, there's nothing bigger. Okay, if I knew it was ascending, that would mean that triangle had to be smaller. And this would become irrelevant, and vice versa. Or similarly, if it's descending, then I know that triangle is larger, but still making this irrelevant. So it is definitely no order. Okay, so that means that, let's see, since I think I'm gonna, let me go ahead and type it up, that I'm gonna deduce no order. That means that what are possible solutions? So if it's a 3, it would have to be 3, 5, 1 because it can't go 3, 1. There's no 5. So yeah, it'd have to be 3, 5, 1, and that's the only possibility for 3. If it's 5, then it would have to be, it can't be 5, 3, 1 because that's descending, and we already said it has to be no order. It would have to be 5, 1, 3. So yeah, we have to test basically criteria card A. Well, no, it can't. Yeah, hold on. Yeah, I'm looking at triangle. Yeah, so it could either be 3 or 5. And so, again, I think my gut feeling goes for the 3, which is what I have. But it'd be 3, 5, 1, obviously. But yeah, I think we got to test A. Okay, so yes, it's not 3. So again, here we're going to say that triangle, let me see, we'll say triangle, since we already crossed out the 1, triangle must be greater than 3. And let me move these solutions a little bit further to the right to make it look a little bit better. Okay, so yeah, so it's not 3, so it can't be this answer choice. And so it must be 5, 1, 3. And so let's type that up. So 5, 1, 3. And just quickly, is triangle the first digit greater than 3? It is. All digits are odd. Yes, there's no 4. Is it true that the first is larger than the last? Yes. The sum is odd. No pairs and no order. So let's go to turingmachine.info and verify. 513 is our solution. 513. Excellent. And now let's go to Turing Machine, or let's verify how we did versus the Turing Machine. And we did do it in 5, so that's always good. So we skipped F. First round was B, D, E, and then AC in the second one. So B, D, E in the first. So B, D, E. In the second round, we did A and C, and of course we skipped F. So, okay, so we beat it by one, right? That one criteria card, the no order, the one that we deduced, really helped out. So, yeah, I think, like I mentioned, the first round, those combination of cards really helped us, you know, limit it to just distinct odd digit solution. And then, obviously, the deduction between criteria card B C and F helped us establish that there was no order. You didn't even have to test it. So you already had that going. And then, of course, what was it, criteria card A and C to further isolate the solution. Well, if you have any other thoughts, please share them in the commentary. And if you like the video, please do give it a thumbs up so that other people can find this channel. And if you don't want to miss out on any future videos, please hit subscribe to be notified. Well, until next time, have a great one.